and good evening, standoff. Yet another presentation is to be divided by leader in Center, John Lambert.
Thank you. I'm really glad to be here. Thank you for everybody staying late to watch this live. I really appreciate it. One thing that I think is why events like this are important is the mindset of attack and defense. I believe to really know how to defend things, you have to have the mindset of attack. And those mindsets, not only are they intertwined, but I feel like the spirit of them and the appeal of them has a global reach. And events like this certainly show that to me. And they are super important these days. I feel like often as defenders, though, we hear about attacks at the same time in the news, but yet we go and defend alone. And we know that that path to mastery of how to get effective at defending, it is a hard fought set of skills that you need to build. It is really the school of hard knocks. You have to spend a lot of time in incidents, slogging through logs, analyzing things, trying to build those skills of detection and investigation and so forth, incident after incident. And so you kind of wonder, if there's anything that could speed the journey of that learning, in InfoSec, that would be a great profession to do it. And they say it takes 10,000 hours to make an expert. What if we could help bend that path to mastery so that you could be an expert in 8,000, 6,000? How would that be possible? Well, today I want to talk about how an open, vendor-neutral, community-based approach, I think, can help shorten and speed that path to mastery. And that's some of the ideas that I'm going to talk about today. All right, let's get started. So there's this proverb that I really like because I think it's very appropriate for the community-based approach here, which is, if you want to go fast, go alone, but if you want to go far, go together. And anybody that's ever worked and pitched in on a community-based project, I think understands this. Like whether you're coding something up or going and exploring something, yeah, you could go by yourself and you might be able to get there faster, but when you're armed with the power of the community and really the value of all the contributions that people can make, that effort can go so much further. And that spirit of that proverb, I think you'll see embodies pretty much everything I'm going to talk about here today. So my talk is going to go over these 4 different areas that are really about things that stack together and how each one is essential, not only by itself, but as they are used in combination to gain the benefits of what I'm talking about today. So I'll first talk about organized knowledge. You can't defend anything if you don't understand it. You can't detect anything if you don't see it. And so I'll talk about how knowledge is important for that. Of course, knowledge is created on its own, but it doesn't do anything in the world. You have to apply it. And so how do you get that know-how to become executable? So it actually translates from the learning process to speeding you up at your job. And then once you start detecting incidents and investigating things, you need to speed up that process of analysis. A lot of analysis, if you ever spend any time in a SOC, it's a lot of time staring at spreadsheets, staring at portals to understand what the data looks like, clicking on it, analyzing it, and then answers come up. But how do you make that? How do you understand what somebody did when they analyzed it? How do they get to those answers? And more importantly, how can you repeat that process of what they did and repeat that faster? So we'll talk about that. And then lastly, I'll talk about the importance of community. Okay, so let's start with organized knowledge. Okay, so all of you in this audience, I'm sure, are going to be familiar with a Mitre Attack. In my mind, it's one of the greatest contributions to the world of InfoSec, maybe only rivaled in concept to the cyber kill chain itself. As you know, these techniques, many of them are contributed by the community, and they help understand all the different kind of attack techniques that defenders need to know about. You can drill into any one of these. This is one of my personal favorites. This is an attack technique T1015. It talks about abuse of accessibility features. And there's this attack in Windows called the sticky keys attack. And the way that it works is if the attacker gets admin on a machine and they know they may lose that administrative access because the defender may find them, they want to preserve their ability to get admin again. And they can do that by abusing the built-in accessibility features of Windows and by setting some registry keys here. And so if you're not familiar with the attack, it's definitely used by red teams all around the world and by real-world attackers, and it's very interesting. So Mitre Attack gives you all the information you need to know about these kind of techniques and some of the technical detail about how to understand them. Another thing that I think Mitre Attack has a lot of promise in the world of threat intel, which is, while this is sort of the universe of attacks, Mitre Attack is not meant to capture every possible technique a researcher could come with, but it's really meant to be the ones that are seen in real world attacks. The Attack Navigator tool, which is what you're seeing here, has a way to go and select the definitions of various APT groups as they're tracked by different threat intel vendors around the world. You can see here, APT 1, 12, et cetera, in the drop down, and you can select those, and then it will highlight just the techniques that are known to be used by that APT group. And where that's really important as a defender is, the reality is you face multiple attackers, and maybe it's hard to get defense across all of the universe of techniques, but if you can focus on the ones just known to be used by the threat groups that you need to prioritize, this is a great way to do it. And I don't think we'll ever, get to a world where every threat intel shop uses the same names for every group, and we have one definition. Unfortunately, I'm not sure that we'll ever get to there because everybody has a different way of seeing threat groups and so forth. But I think where we could get to is a world where threat intel vendors describe the techniques that are known to be used by the threat actors that they track, and then you can go select them and then see how each of them sees the different techniques that are used by these threat groups. And you can almost imagine this turning into a heat map where not only do you see the most common elements used across all the threat actors that you need to worry about, but also you can apply this view to your detective controls and see, do you have gaps in your detection techniques for some of these areas? Or are you strong in other areas, and so forth? And so one thing about this Attack Navigator is it's called Mitre Attack Matrix for Enterprise because it's really about what I would call the traditional attacks against on-premises environments that have, they have an Active Directory, they have file servers, databases on premises. It's a traditional, what I would call like lateral movement-based attack life cycle, where you're going from system to system, box to box, gathering credentials as you go. And then the question is, how does this change with cloud? Many of the concepts behind these techniques, of course, are going to be similar, but the specific notions of how these techniques, how reconnaissance work and escalation works and persistence is going to be different for cloud. And how does that work? So one thing that we've seen at Microsoft is if you go back to around 2016, 2017, researcher interest in Office 365 really started increasing. Every month, there was a new blog about a new technique, a new tool drop, maybe at GitHub, a new presentation of different ways to do all of these different kind of attack methodologies. And then not only that, but we saw attacks in the wild being described by Mandiant in their MTrends report, and then Microsoft has its own investigative team called DART that assists customers with intrusions. So across the research and attack spectrum, we started seeing adoption of techniques specifically aimed at cloud services, in this case, Office 365. And a number of months ago, I put together this chart, which is sort of, if you look at the attack lifecycle and you want to know how do you do reconnaissance, compromise, persistence, I started looking at the different techniques that were published by security researchers around the world seen in attacks. And this is sort of what a cyber kill chain looks like applied for Office 365 and AAD applied there. Each one of those underlying links refers to some publicly documented technique to do these things. And so clearly, having a Mitre Attack for the cloud makes a ton of sense. And I'm happy to say that vendors like Microsoft and others and researchers started contributing those techniques, not to some other repository where you need to know about that, but trying to get to that place where defenders have fewer places to go to understand the things they need to know. And so Mitre Attack in October, over a year ago, announced additional platform coverage for cloud, and Microsoft was a contributor to that here. So you can see there's a drop down in sort of the bottom right where you can select Azure AD, you can select AWS, Office 365, other SaaS applications. Select those, and then you get to see the kinds of techniques and sub-techniques that apply to cloud. Okay, so that is kind of a stroll through knowledge, and I hope you get a sense of trying to organize knowledge, curate it, have fewer places to go to get the information that you need. That is making and simplifying life for defenders, and that because of how successful Mitre Attack has been, vendors like Microsoft, researchers, they're all trying to contribute those techniques and ideas to that to have it be more of a one-stop shop. Okay, so while knowledge is great, knowledge doesn't do anything in the real world by itself. You still need to call that knowledge into action, and I'm going to talk about some ways to do that with executable know-how. Okay. So I'm going to start off with this advisory. So this was an advisory put out by Assert a few years ago. In a way, it was a great advisory. It had lots of detail in it. You can see this thing in the foreground. This is talking about some cyber-related attacks. This was a batch file that the attacker was using. There's a lot of detail in there for defenders to really go and grab onto. There's registry keys the attacker set, backdoor accounts they added to the administrators group, with specific names, reconnaissance techniques, and so forth. And this is pretty common in cyber alerts from cyber agencies all around the world. And while this is very useful and actionable for defenders, one thing about it is every defender around the world, every SOC has to take this and now do homework. And that homework is, all right, how do we translate all of this behavior that's described into something that we can go look for? Rules we can put on our SIEM, how do we go search through these different logs for it? And you can see I've put in the foreground, this is how you could translate. You can look at all of those commands the attacker is doing, and they leave their, like they say, there's this famous phrase in detection, which is every contact leaves a trace. And so each one of those commands is going to touch the registry, maybe touch a logon event, spawn a process, and this is the query language of one of the Microsoft products, Microsoft Defender for Endpoint. And what it is showing is you can write a query to look for those things in the query language of your defense tool. Now, naturally, if you're using a different tool, you'll come up with different queries for it and so forth. So the thing here is each one of these, every defender around the world has to do this translation. And wouldn't it be nice if, in addition to providing the background threat intelligence about this attack, they also provided the ways for defenders to get immediately started with looking for this activity. And so I want to talk a little bit about a project called Sigma. Sigma is a project designed to help for this exact scenario. I think many defenders around the world are familiar with Yara and its flexibility. And if you want to look for some content in a file, an executable, some packet capture maybe, you can write a Yara rule and it knows you can apply that to a lot of different file formats and use it to search. Well, Sigma aims to do that for logs. While yes, defenders have to investigate files forensically and so forth, most of the time they're living in the world of logs. And it would be great to have a universal language where you could describe the most common things you want to look for, and whether you were looking for logon events, process creation, registry audits, you name it, there was a way to have a common syntax that could write those rules that you want to write. So Sigma is an open source project designed for exactly that. The project also has a ton of different rules. If you look at the top, this is all on GitHub. This is the directory. You can see there's rules for Windows, there's rules for Linux, there's rules for web-based applications. These are specific rules that work on Sysmon, the popular tool by Mark Russinovich. And then when you drill into them, they're all specified with a YAML syntax here, so it's very clear and easy to read. And it's not in sort of it's not in the syntax goo that I showed you earlier, which is specific to some query language or query tool like Elasticsearch or something else. This is specified in this declarative way, which is helpful because it also makes it very clear what you're looking for, and then the detection itself is self-documenting. So the rules themselves in a new query language would be pretty useless to defenders if it did not come with the ability to translate those rules automatically into the tools that defenders use. So that's the other half of the Sigma project, which is, a lot of the detection know-how and rules are authored by Florian, and then his co-conspirator on this project, Thomas Patsky, helped really do the back-end translators. And you can see on the screen here, there is translator support to take those generic YAML-oriented rules and translate them into Elasticsearch, Splunk, and many ArcSight, many other Defender tools that you use. So all of those tools on the repository, you can get immediate mileage out of them. So I'll show you an example of the translation in action here. So this is a website, uncoder.io, that's done by SOC Prime, and it's an open tool where you can go on the left, choose any of the different Sigma rules that are there. This one is picking that sticky keys backdoor that I talked about earlier on the Mitre Attack. And then on the right-hand side, you select what provider you want to use to do the translation. And it's sort of like Google Translate for language translate, right? You go say, I want this to be translated into the Windows Defender syntax, or no, I need it in Splunk or what have you. You hit the button and you get this translation, and you can immediately go and apply it. And so I hope you can start to see now, if you have the right knowledge documented in Mitre Attack, and then you come with the detection for it in Sigma, now defenders all around the world can start with not just with a description of what to look for, but with hits on their seam. Okay. So this is just showing what it would mean to take that rule, plug it into a tool like Microsoft Defender for Endpoint, run it, and start seeing results and hits. Okay, so that's executable know-how. So if you apply those techniques, what you're going to get are hits in your logs, and now you need to analyze them. So I want to talk about some tools that can help speed this process of analysis here. If I was there live with you, I would ask you how many of you have heard of Project Jupyter, another open source project. I find a couple of things about this Project Jupyter, which is the two audiences that have heard about it the most tend to be anybody that has done work with machine learning or data science, comes from a background or took a class on that. This tool set of Jupyter is widely used in that area. The other population that has often heard of this is anybody that has graduated recently with a technical degree in computer science or any related field like that, because at universities, they're using Jupyter as a teaching tool. And you'll see why it's valuable in a teaching tool in a second. And the Project Jupyter, why is it called Project Jupyter? If you look at the elements of the name, Project Jupyter, if you look at the right, this is one of the fundamental concepts in Jupyter is the Jupyter Notebook, which is sort of a web-based application. And it basically has a way to type input and then get answers back. And those answers could be textual data, or over here on the right, you see this visualization. And the process of analysis is often composed of those things where you go and fetch some data, you do some analysis on it, maybe you visualize it, you interact with it a bit. And the notebook is capturing all of that activity that you did and rendering it in a visually compelling form. And then the name Jupyter comes from the fact that while on the right, it's using Python, that's what the PY in Jupyter stands for. There's actually a number of kernels, as they're called, that Project Jupyter can run on. If you don't like or want to use Python, you could use PowerShell. If you don't want to use that, you want to use C# or something else, there's a number of different sort of like kernels of language support and runtimes for Project Jupyter. So Project Julia is that's where the JU in Jupyter comes from. And then the R in Jupyter comes from the world of data science, where R is a very prevalent application used to do data science. Okay. So if you've never heard of it or are new to it, one, know that Jupyter Notebooks have a vibrant ecosystem out there. Every single day that us security people are working hard, there's a completely different set of people with an open community working at making this technology better and advancing it every single day. There's over 2 million notebooks on GitHub that have been created and shared to lots of people. It can basically run anywhere. Doesn't require the cloud, although all the major cloud vendors support Jupyter Notebooks. Google does, Amazon does, Microsoft does. And you can also just run it on your own machine, or you can run it in sort of a client server environment on premises. So it basically runs everywhere. The key aspects of the notebook, though, for what we're going to talk about here is, so after you create your notebook, and I'll talk a little bit about that in a second, because the notebook is just a file, you can easily share it. You can upload it to GitHub. You can share it with somebody else. You can create a repository of them in your investigations to share within the SOC. That notebook has a set of cells in there and it is runnable. So you can just execute each step. And now you can start to see if you can run the notebook, it's possible for others to repeat the work that you did. And then the whole notebook ecosystem, because it's Python and open source, it's completely extensible. So one of the tools that Microsoft has created here is called Mystic Pi. I'll say a few more words about that in a second. But the Jupyter world is really all about anything that does data analysis. That is the heart and soul of that community. So data science, analytics, business analytics, machine learning, that whole world, it just works very well with. Now, that world is not necessarily a security world. And so in security, we have data types that mean a lot to us, IP addresses, hashes of files, and so forth. And then we have visualizations that are very important to us. I think if you go look at any sort of software that's designed to, say, give you a dashboard, they have things like pie charts and line charts and bar charts, no problem. But often in the world of security, those visualizations are helpful, but we need to view things in a different way to look at it from a security perspective. And so, for example, the kinds of visualizations that are more important to us in security are visualizations that render things in a graph. So you can see a network of dependencies from a server to a domain controller, maybe to an endpoint, its dependence on a file server. So graphs are very important. Timelines are very important in security, especially when analyzing lateral movement. This set of activity happened on this machine, overlay that with activity now happening on this other machine where maybe the attacker ran PS exec. So viewing things in a timeline is very important. And then hierarchies. Think of a process creation hierarchy where something got started on a machine, maybe a rogue PowerShell process. And as a defender, you need to know what started that process. How did that come to start on that machine? And that parent-child relationship is very important. So the point is, for when people need to analyze data from a security perspective, sometimes there's this gap between data analytic tools and libraries and the kind of security lens you need to put on it. And that's what tools like Mystic Pi are there to do. Like I said, it's open source, it's published by Microsoft. We've had contributions from VirusTotal into it as well, and it's all available on GitHub. So I'm going to show you what some snippets are from these Jupyter notebooks here. So this uses Mystic Pi, and what it's viewing is it fetched some data. And again, you can get, anytime you have data from a data source that you have, you can map it into Mystic Pi. And this is showing you a time series analysis, in this case, of bytes going out of the network. So think of this as egress traffic, maybe from a firewall. And what you notice is there's clearly a work week effect here. You see 5 days in a row of steadily increasing output and then dips on the weekend. And if you look carefully at the chart, you'll see that these extra dots on the chart kind of floating there in orange or red, and that's showing you outlier data transfers. And so the goal here is maybe you're trying to find attacker exfiltration. So a burst of maybe an outbound transfer that is just doesn't make sense for the normal pattern. This is how you see the normal pattern. Or maybe an insider threat scenario of somebody on the weekend trying to download and steal a bunch of documents. So this is one example. This is a parent-child visualization to visualize a process tree and decorate it with a bunch of context that people need to know. And so even though you know, a SOC person may not know how to create this visualization, they don't need to, because tools like Mystic Pi make that easy to do and render that within the notebook. Defenders often need to go and enrich their incident that they're investigating with additional detail. This IP address, does any threat feed already know about it? What does it know about it? And it has a number of different providers for different open and available threat feeds. And you can, if you have an observable you want to enrich, for example, this IP address, it will go off and fetch any information about those and render those into the notebook. And those are just a few examples. I think we've published 20, 30 different notebooks just from Microsoft. You can see they are there's a whole array of different scenarios you can apply them. So I hope you get a sense of the power in a notebook, the versatility of it, and how it can use and stand on the shoulders of the open source and Python ecosystem in terms of all the different things you can do there. Now you can connect to your security know-how. Okay, so that's a little bit about the richness in Jupyter Notebooks. And it's a useful tool for doing analysis for sure. I hope you'll give it a try if you don't know about it. But one crucial thing where I think it gives a power up here is because a notebook can be, not only can you use it interactively, you know, type queries, you know, enrich the data and so forth, like I talked about it. But once you have your sequence of steps in the notebook, you can just run them. So at the top of the notebook is a run all cells, and it will just go through step by step and execute every step in sequence. And now that gives you a powerful automation primitive. There's an open source project called Papermill. It's by Netflix. Believe it or not, Netflix is a huge proponent of Jupyter Notebooks. You know, if you use Netflix, you know it's often recommending movies to you or television shows. The next one, what's the match rate? It thinks you're going to like this show compared to the one you're watching. Well, all of that is data science and machine learning. So they have a huge investment in this Jupyter ecosystem to really make it so that, you know, everybody at Netflix can use these tools. So one of the tools they created was they want an analyst may write a notebook, maybe building a recommendation algorithm, and then they want to run that every night and train it. Well, Papermill is that automation where it lets you to take that notebook and basically schedule it and automate it. So it has stuff in there to help you parameterize the notebook so you could give it different inputs easily and then get the output from it and then orchestrate the running of it. And if we apply this to the SOC, you could imagine you have a hunting hypothesis and you want to run it every day and you want to look at the hits of that hunting hypothesis. But you don't want to just get the raw results of a query. You want to filter, enrich, etc. The notebook allows you to encapsulate all of that. And then with Papermill, you could say, run it every day. And now you start with results instead of having to start with running your query. You can also think of this as how you could start to build run books or playbooks for different scenarios. If an alert fires and you know you want to do steps 1, 2, 3, 4, 5, 6 right away, get some additional context about the host, about the user, what else is going on in the machine at a particular time, are there any other alerts on that system recently? All of those sort of typical triage steps, you could build a notebook that does that and then run it anytime that alert fires, and now you're getting that sort of customized runbook. And so the cool thing here, I think, is in the SOC, it's very common for the SOC world to be divided into two halves. One half is the world of the analysts, and the other half is the engineering and automation department of the SOC. You know, they're there to take away the toil from the SOC and say, find ways to automate everything they need to do. This area, if analysts can learn how to use Jupyter Notebooks and you have things like Papermill deployed, now analysts can automate their own work. If they can do it in the notebook through analysis, then they can start to automate their own work away without having to swivel chair, file a ticket, ask somebody to do some other, get this in a backlog and sort of do it. They can go do it themselves. And now I feel like analysts start to get in charge of their own productivity of this and start to get very, very efficient. All right. So, you know, we've gone from the world of knowledge to making that knowledge executable with projects like Sigma, and then Sigma will generate hits in your logs, and hope you see how we can encapsulate the analysis that goes on with investigating those hits in Jupyter Notebooks and make that repeatable by others because you can share and people can run them. The last segment here is community and how vital community is. I'm sure all of you participating in this event can understand the importance of community. Here are just some examples of how community is important. So Florian, who is, I mentioned, sort of the brain behind Sigma that I talked about earlier. He also has a YAR rule repository online that you can contribute to. This was a particular Java type of attack where if you had a file with these particular commands in it, you knew this was an instance of the attack. And then I created a YAR rule for that and I submitted it to Florian's repository. And the benefit of doing this, of contributing not just the rule to what I had, but to this repository, is these rules now apply to any submission to VirusTotal. And so you start to get the power of, any person's insight that contributes to this project now is applied to every sample. And it's like having your own antivirus detection that runs on every sample and is providing the community with that know-how. This was another YAR rule that I submitted. So one thing, if you're not familiar with this language that I'm about to describe, the way on GitHub or with Git in general, the way you contribute something is through what's called the pull request. So you come up with your contribution, your file, in this case, my new YAR rule. And then when you're ready and you want the master or main repository to incorporate it, you invoke what's called a pull request. And then the repository owner will go look at it. They can have additional checks on it, validating it, and so forth. In this case, you can see Florian, who at this point, I had never met him before. He's just, the maintainer of this project. He goes and looks at my contribution, says, oh, did you know you can optimize this? You can optimize that. So in the process, I learned how to write better YAR rules. And then he made those changes and then pulled it into his repository. And then, like I said, now it's run on every submission to VirusTotal. And I just hope you see, if you know anything about an attack through this open community approach, now you've just empowered everybody in the community to benefit from that insight that you had. Another super important community effort, the community would be nothing without the participants in the community. So there's a community effort called OSCD, for Open Security Collaborative Development. Hope you can see there, it's run by Daniel, and they do sprints. And the idea behind the sprints is there's areas that if we all band together, we could do a surge and really improve coverage. And so they did a sprint last year to beef up the number of Sigma rules. And I hope you can see here, this is sort of a progress report. 144 Sigma rules were created in this particular period of time. You see one of the top sprint participants, Thomas Patsky, who is the co-owner of the Sigma project. And then people from all over the world, from many different countries, feeling that spirit of defense and contribution, participating in these things. So I think these things are great for helping fill gaps out there. And this fall, there was another round of the sprint, and there were, again, a number of contributors from all over the world. Yes, additional Sigma rules was part of it, but also testing with the Atomic Red team, and there are a number of other areas were part of these sprints. And so there is a lot of energy in the community. It is a great way to get to know other people in the community by participating in these things. And then I hope you can see the expertise of all these individuals being contributed through pull requests to these common projects. Now every defender gets to benefit from their excitement, their energy, from their contribution here. So that leads me to sort of kind of wrap up this talk with what I call the GitHubification of InfoSec. It's a mouthful, so I'll explain how these things tie together. So for a minute, if you can imagine a world where every threat group is described not just in some long form narrative, but in terms of the TTPs that they use as expressed in the Mitre Attack matrix. And that the Mitre Attack matrix, as new attack techniques evolve for on-premises attacks, for cloud, for industrial control systems, IoT, cell networks, you name it, those techniques get studied and embodied as a Mitre Attack technique in a technique database. And those techniques, each one of them, defenders around the world through efforts like OSCD and just independent researcher work, are working to provide out-of-the-box detection definitions for how to spot those attacks in the wild in logs. And through projects like Sigma and Yara. And as that coverage improves and those rules are used by Defender products all around the world through the benefits of the translators and then just direct incorporation and support for Sigma. Very recently, VirusTotal showed off some support directly for Sigma. Joe Sandbox showed off native integration of Sigma. And those give you hits and detection products used by defenders all around the world in their SOC. And defenders have created ready-made Jupyter notebooks that know how to go and analyze those hits and build the necessary context around them. And while you can imagine, there's always somebody in the SOC that is really great at what they do. Their know-how is amazing. Their investigation skills are super sharp. And if only other people in the SOC could get to their level of mastery, well, if they can embody what they do in a Jupyter notebook, now in a very concrete way, they have allowed others to get that level of mastery and repeat what they did on their incidents and then their detections. And all of these things are designed to stack well together. And, I'd say if there's any call to action or sort of vision for this area that I can summarize succinctly, it would be sort of something like the following, where imagine a world where for every attack or TTP, we have a Mitre Attack technique. For every Mitre Attack technique, we have robust Sigma rule coverage. And then for every alert type that is generated by those Sigma rules, we have a ready-made Jupyter notebook to start defenders analyzing and speeding and triaging those hits. And you can think of that as a coverage model that maybe as a call to action, we could start to fill the gaps of that and provide this level of expertise and mastery for anybody. So I talked earlier about, it takes 10,000 hours to make an expert and how do you speed that? I hope you see how these technologies all stack together and start to really improve the rate of learning for defenders and get us to a place where community contributions can speed up everybody. So this slide is, if you want to know, how do I get started? Here's some different things to do if you're a developer, a defender, maybe just manage a SOC, or if you work at a CERT, what can you do? These are some concrete things you can go do to get started with the concepts and ideas here. And there is a long form paper I've written about the GitHubification of InfoSec. You can see it here. And through the power of the community, it was translated by community members into the Russian language, and you can find the link there. And they did it through a pull request. And if I could say, within the next 12 months, if you could set a goal for yourself, if you haven't done this, one goal for you to set for yourself in the next 12 months, with that community spirit in mind, if you've never done it, go do a pull request. Find some project on GitHub where you can go make an improvement to code, to detection, to documentation, to samples, and go do the step of doing a pull request. Might be scary your first time. I find project maintainers are very welcoming to it. You can ask other people that have done it before. Once you've done it, it makes it so much easier to do the next pull request and the next pull request, and it's just a great way to contribute to the community. So with that, I'm really grateful to the organizers for allowing me to come and speak before you today, and I look forward to meeting you virtually on Twitter or you name it, in person at conferences in the future. Thank you very much.